design in Islamic architecture. Thesis structure. The thesis is divided into two main parts. First part composes of chapter 2 and 3, literature review and the theoretical background, while part 2, chapter 4 and 5 represent practical implementation of the fractal geometry through the study of the Mamluk Madrasas, followed by the conclusion chapter. Chapter 1, the introduction. The research problem style-based design isn't a result of Euclidean transformation and discrete vocabulary only, but form and geometric evolution process. A clear example of reusing the typical architecture vocabulary is in Sultan Hassan Madrasa and the King Saud Mosque in Jeddah. It takes the same and exact vocabulary for the entrance of Sultan Hassan Madrasa. The main aim is considering the style as a result of evolution process, origin and self-similarity. The main objectives are to analyze the fractal geometry of the Mamluk architecture as an archetype, measure the complexity by the fractal dimension, building a parametric interactive model to analyze and generate fractal-based design. The methodology after the literature review is divided into qualitative approach by the geometric analysis and quantitative approach achieved by calculating and comparing the fractal dimension for the 4 case studies. Chapter 2, Fractal Systems. The harmony of the word is made manifest in form and number, and an object form is a result of diagram of forces, are acting or have acted upon. The 4 major books in this topic is by Darcy and Mandelbrot Benoit, and Carl Govel and Michael Oswald. Mandelbrot quoted that Euclidean geometry created by point, line, plane, and cube couldn't express the dynamic growth and complexity of forms. The complex forms are resulted from a simple process. This is the difference between the Euclidean geometry and fractal geometry. The difference is that the Euclidean is a static geometry and the fractal is a dynamic process. And most of them have been originated from a number of iterations. It's resulted from a certain rule. The rule, for example, if we have a segment and it's divided into 3, then the rule could be if the middle segment is replaced by a triangle, it's continue this process for all the iterations. Self-similarity, which is the major property of it, parametric and scale, recursive and self-affine. These are the examples of the fractal curves, serpentine triangle and carpet and the Islamic star. They all lie between 1 and 2. The value of it lies between 1 and 2. For the 3D forms, there are 2 main examples, the additive cube and the subtractive measure cube. The nature inspired the architecture and sacred architecture particularly to represent the concept of unity and subdivision. The sacred architecture represented in Islamic architecture, Gothic and Hindu temples as well. The Hindu temple in India represents this 3-dimensional fractal geometry. And the Burgess Cathedral and Sagrada Temple as well. Oswald mentioned that there is no ideal mathematical curves or forms in architecture. The architecture is multifractal. An organic approach is presented by Frank Lloyd Wright in the Palmer's house by successive iteration of the triangle. This is the iterations to reach the final plane. The fractal-based design needs to be guided, to be constrained to an external context-based or an internal spatial basis. I summarize it in 4 main points: context-based, spatial-based, structure-based, and analytical-based. These are 4 examples for each case. It's by Salary and Jan Novel, Zah Hadid, and Fai Otto. And there's some trials from the researchers to make the forms an architecture form as a part of the building or as a skyscraper for a full building. Chapter 3 is the fractal analysis. There are 2 main methods it's used to measure the fractal dimension. They use most of the application is the fractal rhythm and box counting. The fractal rhythm is represented by colored bubble, and the box counting presented by Mamluk. Here is an example of the fractal rhythm. There is a scale in the grid in the case of the rotunda or the Willet's house by Frank Lloyd Wright. And the box counting method depends on to overlay the grid on the plan and superimpose a multiple scale of the grids and then counting the grid that contains the lines inside it. This rule calculates the box counting dimension. These are the 2 software I used in the thesis, Benoit and ArchiImage. There are slight difference between both of them in the results, in the format of the results exactly. And the part 2, which is for chapter 4 and 5, it passes by 5 phases for knowledge and preparation, analysis and synthesis, and then the creation process. This is chapter 4. A recorded notice while analyzing the Islamic architecture is that the complexity increased by time, in which in the early period, the simple square shape of the mosque gives a fractal dimension of value equal to 1, while it is the maximum in Mamluk and Ottoman architecture. I choose the Mamluk architecture for a number of reasons. The 4 reasons are that it has a complex pattern in a pure simple form and a spatial hierarchy. The presence of the fractal form is found in the domes, arch, muqarnas, and in the Islamic pattern on the walls as well. From the large scale to the small scale, it is rich in the details. The 4 case studies are Sultan Hassan, Salam, Sultan Shaban, and Amir Khalid. The plans are prepared to be analyzed. All of them have a central square and generated in the 4 directions for the 4 imams. Some examples have another second iteration for example, the Sultan Hassan has a second iteration from these spaces and the new origins at the corners of these buildings. The growth direction are in the 4 directions. These are the examples of the fractal patterns in the Muqarnasat of Sultan Hassan and the floor pattern of the courtyard. And in Sultan Qalawun Mosque has a self-similar arches. They are scaled by certain proportion, the square root proportion. After the analysis, there is a rule definition, synthesis, and creation process. A chart which represents all the other phases to reach at last to the rules that will generate the model. The analysis, this is the proportional analysis of each case, geometric analysis and fractal rhythm and box counting. The results are compared together by bar chart and to calculate the average, and it's shown here that the Sultan Hassan has the maximum values and the Sultan Qalawun has the least values. Chapter 5, the fractal-based design, is computer-generated design using the mathematical algorithm, parametric rules, and recursive process and loop. I used the software Rhino and Grasshopper and Python scripting. This is the common rules in the 4 case studies. It's based and make it based for a datum, which is the radius of the courtyard. And for example, the Qibla Iwan is its width ranges, or its side length ranges between root 2 r divided by 2 times r. Then these rules are converted into the nodes and relationship in the Grasshopper. These are number of variations based on the Mamluk Madrasas. This is a snap from the video. How it shows how the parametric design, when I change a parameter by the slider bar shown below, everything is changed, the whole is affected because it's all related to each other. Chapter 6. The two main parts for conclusion are Mamluk Madrasa exploration as an archetype for similar styles and fractal-based design using interactive models. Tracing the fractal morphogenesis of the Mamluk architecture highlights the beauty of the organized and orderly complexity of the Mamluk Madrasa design. Mamluk Madrasas successfully express fractal characteristics inspired from nature through a self-similar fractal pattern of various scales. Understanding the architecture style by the process of its geometric evolution or the fractal dimension. This methodology enables history and theory researchers, professionals in architecture, to explore and the research might assist designers when introducing a new building that carries the same fractal grid of the surrounding context, a sensitive context. Fractal-based design enables the researchers to understand the style by an interactive model in both analysis and design process. Parametric rules give the opportunity to modify parameters to evaluate the possible changes without spoiling the main constraints and proportions. Atlassian research in studying the fractal geometry of 3D forms, elevation, architecture, and windows, and style transformation design as a trial to be responsive to contemporary changes. That's it. Thank you.